Okay, for number 20, it says write a formula for the probability of getting A or B or C. Use the diagram at the right to help you. This is an inclusive event. Okay, the idea with inclusive events is when they overlap, and certainly we have overlap. Do you see how A and B overlap? Well, A, B, and C overlap right here in this yellow section, right? Do you see that? That's where they all three overlap with one another. That's an important concept there. Do you see that A and B actually, I mean, they overlap in the yellow area too, but A and B, just A and B overlap here, okay? A and C overlap here in this blue section, okay? And then goodness, I'm running out of colors here. I'll make this one red. B and C overlap in this red section here, right? Okay, so that the idea with these probabilities is that there's certain places where if you just take the probability of A, the probability of B, the probability of C, and do what you normally would do, if you, for example, if you do A or B or C, if there'd be no overlap, shoot, that'd be easy. You could just add the probability of A, the probability of B, and the probability of C, and you'd be good to go. Because remember that OR in probability means adding. But the unfortunate thing is that there's some overlap, which creates a complicated scenario. Because wherever there's overlap, it's like you're double counting, and you have to remove those from the total probability. So what we want is a formula. So, like I said, if you just have the probability of A, the probability of B, and the probability of C, if this would be A, B, and C, that'd be so easy. You would just take the probabilities because it's OR, and you would just add them together, right? Okay, so let's start with that. The probability of A or B or C, let's just pretend temporarily that there's no overlap. So the first part would be the probability of A plus the probability of B plus the probability of C, okay? Very easy, okay? But now is where we get busy and start subtracting out all the places where there's overlap, okay? Well, the places where there's overlap, this probability, this yellow probability right here, okay, that could be represented by the probability of A plus B plus C, okay? So let's take that yellow part out, minus the probability of A and B and C. So in other words, the probability of all three of these happening is represented by this yellow section here in the middle. So now we've taken that part out. That's where the subtraction comes into play, okay? But we still have to take this green, red, and blue section out because there's some overlap there. Well, how can we represent the green section? Well, that's the probability of A and B occurring, okay? How do we represent the probability of that blue section? Maybe it looks purple to you, I don't know. But that's the probability of A and C happening. And then, of course, we have the probability of the red section, which we have to take out because it's like we double counted it. So that's the probability of B and C happening. And that is our formula. Now, imagine if you were actually given values and having to calculate that probability. It'd be a little bit more tedious, but at least you know what the logic and kind of the formula is behind it. The idea is that you add the probabilities together and then you take out, here's where this minus is coming from. You take out all the places that are overlapping, okay?